All right, here is the software demo.
Where is the 3D printer?
This printer that I'm going to show you is in Boston, but I have to say thank you to the Golden Tulip for not having fast enough internet. It's a sarcastic thank you. You won't be able to see the video because we're trying to stream in HD video, but what I can show you is everything about it, and I guess you kind of just have to take my word that the video does exist. I'll show you a YouTube video of what it looks like when you get the output. So when you're done printing every time, it creates a time lapse and it gives you a really quick version of the video that you just produced so that you can share it, so that you can look at it afterwards, so that you can see if your design failed, if you oriented it the wrong way and it became a spaghetti bomb, you can see at what point in your printing process that happened so you can go back and learn. What you're seeing right now is who's printing, what they're printing. This is actually the United States Marine Corps Iwo Jima statue. It's a famous American statue, I'm not sure if you guys would know it, but it's from World War II. This is what's next on the queue, the god Ganesha, the Pharaoh, and the Colosseum. So we're just printing out history, which is really, really exciting. This shows you the bed temperature right here. This shows you the nozzle temperature in real time. It tells you exactly how much plastic you have left over, what plastic you're printing with. And if I wanted to be annoying to Morgan, who's printing this right now, I could stop the print job, or I could skip it and go on to the next one. But I'm not going to do that because we're printing this monument for a reason. But here's what I want to do. I want to show you guys the upload feature and 3D print preview.
What's the point of showing temperatures?
Just to show you that it's tracking and it's at the right point. So when the printer first hasn't started printing yet, it starts out cold, and then it shows that it's heating up because you can't start printing until it gets hot. So we show the customer as to why they're waiting at that point. But really the temperature is for us more or less to diagnose if something's going wrong. But it's nice, it gives you kind of a gauge. It's like when you're driving a car, you like to see something. All right. Volcano, let's do this. So, what's really cool, this is our 3D print preview tool. In a second, the volcano is going to pop up right here. And this is why we call it 3D print preview. If my computer would load. There we go, come on. So slow. Note to self, I need a new laptop. Zoom, zoom, zoom. So this is telling you how big the object is, the different dimensions that are there. This is taking forever. So, FYI, because everything's cloud-based, the way that the software works is it uses the graphics card on your computer for all the rendering. So any lag and slowness that you're seeing is completely due to the fact that I have a crappy laptop, not the software itself. I know you guys are gonna have to kind of trust my word on that one, but it's true. Oh, see, I keep catching a snag with WebGL, that's why it's going so slow. All right, here we go. We call it 3D print preview because when you zoom in far enough, it actually shows you the layers on the object before you hit print. And that's really important. That's like when you hit Control P on your paper printer and it shows you the paper that you're gonna print out. It shows you what it's gonna look like. Oh, come on. It's because of the WebGL. Hang on, let me refresh this. It's always fun when demos don't work appropriately. Why is it? Reload, come on. Sorry, guys. There we go. Okay, see how much better that is now? There we go. Sweet. So those are the layers on the object. And when I go to high quality, they get smaller instantaneously. And I go to fast quality, they get bigger. So it just gives you a sense of what you're actually going to print. And if I come here to transforms, I can change the orientation of this object. Right? You don't want to print something like that. But if I come over to advanced, I can set my support material angle. So based upon the angle that I set it at, it'll put a specific set of support material. If I put 90%, it'll put support material everywhere that's unsupported. I don't want to do that. I actually prefer auto support material when I do it. It's better that way. Just come all the way over here. And this is how you can set the pattern. So that honeycomb shape that I chose before, I can choose honeycomb.
Is the supporting material also shown on this preview?
Not yet. That's a difficult software feature to enable. We've been working on that internally. It's not in the product yet today. But the cool thing about cloud software is when we've got it working and we're confident that it's going to work for our customers all the time, it just works. No downloads, no updates, nothing like that. It just automatically gets updated in the cloud experience for you. So with this, now I can come over here, I can mess with my strength, and I really love this sideways volcano, so I'm going to print 4 of them. So I submitted it. Now what it's doing is sending it to the cloud to get sliced. It's going to get sliced. Slicing is the toolpath generation, the G-code creation portion of the process. It's getting sliced in the cloud. And once it gets done sending, okay, it tells me that it's sent successfully. And now if I come over to my approval, I should see that it's there. It might still be slicing at this point. Oh, no, yeah, see the volcano's still slicing. But to your question, this is all I have to do. Approve or deny. I can leave whoever it is a note, but I can come here. Any of you guys a fan of Italian sculptures? No? Okay, that's fine. This is the statue of David. Once it finishes loading, this is an example of what it looks like when you get the view from the admin's perspective. It tells you what quality they submitted at, what infill, what the units that they used, what scale, so that they make it bigger or smaller, what kind of support material they chose, and then how much plastic it's going to consume. That's a really important one. What we haven't done yet, but we're planning on doing in the near future, is equating this to cost in plastic for the customer, so that they see how much it's actually going to cost them to do it. But we give them a filament estimate, right? So this is 89 grams, let's call it 100 grams. It's about $80 a kilogram, so it's like, this is a $7 object, roughly, the statue of David.
What's the problem to change from grams to dollars?
Yeah, we just haven't determined if customers actually want to see the cost or not. We know that the amount of material is important. It's just whether or not they actually truly want it. So here's the statue of David. Poor guy. Yeah, that's his butt. Sorry, I'm a jokester sometimes. Okay, now the volcano's done. I actually don't want to print this volcano because it's a sideways volcano, so I just deleted it from the approval queue. And now when I come here to the queue, this is the coolest part, is this is production planning for the 21st century, which you guys are about to see. Okay, so you remember we saw before the Colosseum, the god Ganesha, and then the Pharaoh? Well, I actually think Julius Caesar is a little more important than the Pharaoh right now, so I just prioritized it. Big companies buy SAP software to do this very same thing and help them figure out how much does that cost, how much is that change going to cost my company? Because of 3D printing, there's no tooling cost, so you can just go on to the next thing with no human input, and that's exactly what we're able to do here with the queue rearrangement. And when all this is done, it's going to print it out automatically. I'll show you what I mean by automatically. So here's a video of a bag of whistles, similar to this, getting printed out. So what it does is it prints the whistle, prints the bead inside, covers up the top, removes it, pushes it into the bin, and there's a bunch of whistles. And it's going to do this over and over and over again. We printed 18 whistles, so 6 batches in a row, and then there was already a bunch in the bin to begin with. You do this with a human, this printer, after the first 3, stops. It stops right here, done. It doesn't do anything else until a human shows up. But we're able to do this throughout the night. So all the time that you normally wouldn't have a person in the office or in the facility, the printer is still doing its job. It doesn't get sick and it doesn't take vacations, which is really important. All right, cool.
How long it takes to print those 3 whistles?
So the 3 whistles took about an hour and a half.
Hour and a half.
Yeah. Which, if you're the human, do you want to show up at Saturday at 1 o'clock in the morning to start it, and then an hour and a half later come back at Saturday at 2:30 in the morning to start the next job? No. Nobody wants to do that. You want to sleep, or you want to go back to the club wherever you were before. You definitely don't want to go and remove parts from a 3D printer. Unless that's your job and you're getting paid for it, but robots are taking over your job, sorry.